Good morning, pre-calculus. Okay, we got another day. Today is the second part of section 10-7, where we're dealing with polar coordinates. And the second part we're going to deal with today is equation conversion. Yesterday, or on the previous video, we did polar conversions and rectangular conversions. And I share with you that this is an important part of this section. It's because we're going to need a lot of this information when we get into Roman numeral 2, where we are going to take information, whether it's a polar coordinate or a rectangular coordinate, and we're going to make an equation. And the equation I'm talking about is stuff that we've been doing up to this point. All right, so let's tackle it. So Roman numeral 2 is called equation conversions. And once again, that's all on page 782 in your textbook. So before we get to those examples, we need to know two things. One, we got to know that when we get time to convert rectangular equations to polar equations, we are going to be replacing the value of x with r cosine theta and the value of y with the r sine theta. Now again, that goes back to this part right here. This is critical. This is crucial. Then the next thing is to go from polar equations to rectangular equations. We got to use a little bit of ingenuity. So some of that stuff I'll talk to you about it. A lot of it is, a part of it is algebra. Some of it is going back to remembering all your trig rules and trig formulas. You'll see when we get into the section. So let's get started with our first one. I have 3 examples, I do believe. So here's one. Here's our first problem. We're going to convert this polar equation to a rectangular equation. So again, the first one they give us is nothing more than a radius of 5. That's all they give us. That's it. That's all the information. And we want to make this into a rectangular equation. In other words, an equation that we have used before. Okay? So the first thing we're going to do is I'll let you know right off the bat that this is going to be a circle. You're saying, what? How can that be a circle? Well, let's go to this diagram. And it already told us that the radius is 5. So if we do some counting, 1, 2, 3, 4, 5, we are going to notice that if we were to look at this graph, it will have a radius of 5 all the way around. And the equation of that is going to be a circle. So if we were to just go and highlight this, okay, keeping it real simple, here is the equation. This is the graph, what it would look like. So all I gave us is a radius of 5. So everywhere around here is 5. So that by just looking at that graph, that is a circle. And we got to ask ourselves, what is the equation of a circle? Well, goes back to here. So x squared plus y squared equals 5. So there is your rectangular equation when all we're given is something polar. Okay. Some of these are going to be very simple. Some of these are going to be we have to do a little bit of thinking, a little bit of ingenuity, like I said in the second bullet point above. All right, number 2. Here we have the angle of pi over 4. And we want to find the rectangular equation that represents pi over 4. Now again, some of these are real simple. So if I look at this page right here, and we already know that pi over 4 is 45 degrees. Okay? That's all they give us. They just give us all they gave us is theta to be 45 degrees. This right here will be, in the sense, the equation of this. I can't even see this. My bifocals are giving me fits. Oops, am I going to be off? I'm going to be off a little bit. There it is. This right here would represent the equation of pi over 4. And if you look at that, that's an equation of a line. So we can go and tie into it using our rules from over here. We know tangent of theta, pi over 4, has got to equal y over x. And if you do your math, pi over 4, which is sine over cosine. Okay, so if you go to pi over 4, sine is, you can figure that out. It's going to be radical 2. My brain's not thinking too well. You'll get it. So it becomes 1 over 1. So that, once again, this is your y value, this is your x value, and it just ties into, more than anything, again, going back, how do they go from here? Well, we know that tangent of pi over 4 is 1, so that we know that 1 equals, in this case, y all over x, cross multiply, and we see that x equals y. So this would be the equation, the rectangular equation of this polar coordinate. And I showed it to you 2 different ways, algebraically or graphically. Okay. All right, now the third one is going to get us to have to put our thinking caps on a little bit. Not much, just a little bit. Here's this one they give us is the radius of 1 all over 1 minus the sine of 2 theta. And we want to take this polar equation, that's what this is, and make it into a rectangular equation. All right. So first things first is cross multiply. So I multiply both sides, cross multiplied. And this is where the ingenuity comes into place. Again, distributivity. The next step is we're going to get r squared minus 2r squared sine theta cosine theta equals 1. Now you're saying, whoa, where did all that come from? Okay. Like I said, this is where we got to do a little bit of thinking. The first part is we have to get it into this form right here. So again, to get it in this form right here, I'm going to square my r's. And then you're probably saying, where did this come from? Well, that came from your double angle formula. We know the sine of 2 theta is 2 sine theta cosine theta. So, once again, make your r's to become r squared. Goes back to these rules. Okay, once again, our goal is to go and get this as a rectangular equation. Now, this one's just set up as a circle, but we have to figure this part next. Okay. So we know that sine 2 theta, just that part right there, is 2 sine theta cosine theta. That's what I'm saying. We got to do a little bit of ingenuity. We got to go back and use some old rules. All right. Then the next part is we know that this is going to be 2. I did a little bit of distributivity. So it would be 2 times r cosine theta, r sine theta. Now I put it in this form because, like I said, we've got to go back and use some of this stuff here. Okay? You'll see. So we could keep going. Well, we already know that r cosine theta is x. Well, we already know r squared. R squared is x squared plus y squared. Okay, so r squared is x squared plus y squared. Should put a little parentheses around that. Minus 2. Well, we know that r cosine theta is x, and we know that r sine theta is y. Okay, x, y. And our equation will be this equation right here, which is one of those problems that we did back in a previous section. Rotated conic. Just not thinking too well. Okay, so this is what this section is all about. Equation conversions and coordinate conversions. And once again, this is the critical part of this section. And then also, if you want, go to the Google like I did, look up polar coordinate graph PDF, and you can print these up. They're all free. All right, so I'm going to stop right there. This is part 2. We'll look at section 10.8 another day. Catch you later.